Okay, so skill 12 was applying parametric equations to situations involving projectile motion. And so we had to choose an integer, otherwise known as a, which was between 85 and 95, and another integer b, which was between 250 and 350. And then we had to determine the angle required for a baseball to leave the bat with an initial velocity of 8 miles per hour and first hit the ground b feet horizontally from home plate. And then if contact is made 3 feet above the ground. So I chose 90, and that would be my velocity, which is 90 miles per hour. And then B I chose to be 300, which is the distance traveled. And also, like in the problem, it was given that if contact is made 3 feet above the ground, so that 3 feet is the initial height. So the first thing I did is I drew like a quick diagram. And so basically we had to find theta, we had to find this angle, given this velocity, this distance traveled, and we knew the initial height. So there's two equations that you would use. X equals velocity times the cosine of theta times t, and then y equals negative 16t squared plus velocity times sine of theta times t plus the initial height. And then the initial height, which is h sub 0, equals 3 feet. So the first thing that you had to do is that, first I had to convert this velocity, which is in miles per hour into feet per second, because those are like the units you need. So I just used like simple dimensional analysis and then proportions here. So I first converted it into miles per minute and then miles per second, and then these many miles over 1 mile equals x feet over the amount of feet in 1 mile, and I got 132 feet per second, so that's my velocity in feet per second. And so now you could use these two equations. So the problem that I found at first is that you knew v sub 0 and you knew what x equals, which is 300, but you still had two variables, which is theta and time. And then even in like the second equation, when y would be set to 0, you would still had theta and t as your two variables. So what I did is that I first took the first equation, which is x equals v sub 0 cosine theta times t. I filled in what I knew, 300, which is x because that's the distance traveled, and 132 because that's the velocity. And I put it in terms of t, which would then be 300 divided by 132 cosine theta. And so then you could basically make a system here, and I used the method of substitution, and I substituted this like for t into the second equation. So if this is the second equation, this is what it looked like with this new thing substituted in. And then I simplified it even further until I got negative 82.64 over cosine squared theta plus 300 tangent theta plus 3. And then I used the identity cosine squared theta equal 1 over cosine squared theta equals secant squared theta, and secant squared theta equals 1 plus tangent squared theta. And now I did this so that I would have tangent, like I would have tangent everywhere, and that would make it like easier to simplify. And then it also so then I got to this final equation, like the furthest I could simplify it. And then if you like look at the terms, you'd have like something multiplied by tan squared theta plus tan theta minus another number. And so this was like a sort of the quadratic form. So I used the quadratic formula, which is x equals minus b plus or minus square root of b squared minus 4c divided by 2a. And I solved for theta. And so I got two angles, 16.1 degrees and 73.3 degrees. Now I chose 16.1 degrees as my final answer because when I plugged it in back into the original equation, the time was approximately 2 seconds, while this angle gave me a time of approximately 8 seconds, which is a lot longer than this angle. So just based on the context of the problem and like the probability of it, I guess, or like the more realistic angle would be 16.1 degrees because of like the amount of time it would take. So that's skill 12.